Good morning. Good morning, everyone. This is Thomas, your host for this webinar. Welcome to our webinar session. Just a quick word to introduce before we start with our speaker for today, Stephane. And this webinar is in listening mode only. That means you can hear us, you will hear Stephane hopefully very well, but we cannot hear you. So I'd just like to invite you all to use the chat box to ask your questions, if any. There will be a specific time for questions and answers, and Stephane will answer all the questions from the chat box at the end of the presentation. So please feel free to ask your questions along with the presentation whenever it's coming, and everything will be answered at the end. So today webinar topic will be about metering solution, how to measure and communicate efficiently. And our speaker for today is Stephane Kretz, Product Range Manager for Energy Management based in Aubernais in France. Hello, Stephane. Good morning.
Hello, Thomas. Thank you. And hello, everyone. Thank you to be with us. As Thomas said it, the topic of today is metering, more specifically sub-metering, the meters that you have to can put in your installation. And we will see why it's important to have it, what it can bring to you, and I will show you the agenda that I will propose to follow concerning this. Why is energy measuring important? Why do we need to measure and to meter our energy at the end? What are the relevant data to follow and monitor? What could be interesting to monitor? And for energy management, what is specifically important? How to select the right meter once you think it's important to measure, okay, but and you know what to measure and to monitor is what is the right meter for the right application. How can you define that? And then once you have defined what you want to measure, where and so on, it's do I have to monitor it and to see where to put it and where to read it, perhaps remotely to analyze and so on, and application and main benefits you can get from this. And then to finish, what are the Hager solution in order to answer this topic. So this is what I want to present you today and to follow in the presentation. So why is it important to have energy measurement in your installations, mainly in commercial, but also in residential? But the focus here is more on commercial applications. Building and energy consumption, okay. First, on the left on your screen, you can see what is energy consumption in globally used, and you can see that the main consumption, you can see it's 44%, is in the building. Of course, you have also transport that is important, 1/3 approximately for transport. Industry and siderurgy is 21%, a little bit in agriculture, but not so much. But so if you want to reduce the energy consumption globally, I talk about green and ecology here. The main topic where you can work on and to reduce the CO2 footprint is building. So if you go into this building, where do you use energy? This is also important. For the next topic, what should I measure, follow, and to do what? So the main topic is HVAC, 55% average is used for HVAC, heating, ventilation, air conditioning. Then you have the plugs for different machines. Lightings is 12%, hot water 10%, and the rest 5%. So it's also interesting this split between usage because it's important for to know what I need to measure in order to understand what happens in my building. So what you have to differentiate also in this way is what can I do with what I measure? I can measure for power quality. That means the quality of my energy. Here is my energy available. What can I do to have available energy? It's important in some applications, of course. This is a service continuity. What is my power quality? That could injure my, if I have not the right power quality, I can injure my my devices, and the time life of my devices can be reduced, and this is a cost also, and you can save money. So you can do preventive product maintenance. So an example is, for instance, if you have a fridge or in a supermarket, and you can have alarming if it's a day off, and that's all what you have in the fridge. If the fridge is no more working, is not consuming energy, or if you have a power cut or something like that, you can lose all what you have in your fridge for your supermarket or for your restaurant or something like that. So easily here, as an example of application, you can save really big money if you have the alarming that you have a problem. And to see that, you need to measure. Also comfort, it's good to measure and to reduce the consumption, but you have to keep the right comfort for the people that are for the workers that are in the building. And then you have energy management. Energy consumption is optimized. If you have, if you can see where you use energy, and if it's at the right place and the right quantity at the right time, and it's concerning electricity, gas, hot water. So you to see that, you have to split and to see the detail in zone and usage. And what I said before is, if it's HVAC, you have to identify if you are using HVAC not in a normal way, and this is important. And also where you can save money, it's if you have a tariff in your countries, different tariffs, high tariffs and low tariffs. It's good also to manage it and to use the energy, the electricity in the low tariff period. And for this, you have to measure to understand where you use and when. Also for load shedding, it's important, and alternative energy management. If you are producing locally energy, could be interesting to use it when you are producing, and to manage your loads linked to this. So, but again, to do that, you need to know and you need to measure. Okay. So this is known, well known, and everybody knows that. What Peter Drucker said, you can manage what you don't measure. And it's to sum up what I said. In order to manage, to pilot, to control, you need to know. And to know, you need to have the right measure at the right place. So it's also driven by standards. The standards that are applied for this, you have two main standards concerning this in commercial business. You have first the IEC 364-8-1, that is based on the energy efficiency of your electrical installation. And for this, we can see it on the small graph that you are on the right on the picture. You have on one side the source of energy, grid, local production, local storage. This is the income, and on the other side, you have the loads, the use of the energy, the different loads. And in the middle, you can see energy efficiency management, and to manage that. In order to manage this properly, you need to measure. It's what you can see in yellow in the presentation here. You need to see to measure in order to do your energy efficiency management efficiently. And in parallel, you have ISO 50001, that is the standards concerning the efficiency of your production site or buildings and so on. For this, you have a plan to be more efficient in your consumption on your site. And for this, you need to measure also in order to understand where you consume and what is the action plan you can do in order to reduce your consumption. So I said it before, there are two things, energy management and power quality. Here I will focus on energy management, so energy. Now that we said we will focus on energy, what are the relevant data in order to follow and to monitor this? So you can measure many things in electricity, for power quality and for energy management. But clearly, I put here, you have measurement units for quantity, what I consume, current, power, energy, and you have for quality, voltage, cosinus phi, frequency, THD, harmonics, temperature. Okay, here for what we want to, for energy management, clearly, we will focus on energy monitoring. And this is a recording, consists to recording active energy in consumption and production, because of course, I said it, it's also, if you have PV or something else, it's also important to understand what happens in your production in order to manage. And it's expressed in kilowatt hours or watt hours, depending on the quantity you will measure. I will say many kilowatt hours is used for this. So let's focus on this for the presentation, during the presentation, and for your applications linked to this. But then when I say that, kilowatt hours, okay, it's important. Energy, electrical energy is the main value where we will focus on. You have different standards, and what I was, sorry. What is important also is what I measure. Is it correct what I measure? And for this, it's accuracy that can give you the reliability of what you are measuring. And thanks to certification or to standards, you can be sure that what you are measuring is what is really consumed. So in Europe, we have the MID certification linked to this, and it's a standard, an European standard that is linked to this. And what we recommend, and what is recommended by this MID certification, is to have class B, that is 1% accuracy on your measurement. It's very interesting, this MID certification, because it's what is used if you want to bill your energy consumption. It's used for electricity, it's used for gas, it's used for water, and so on. The MID is more larger than only electricity. It's really when you want to get a bill for the energy you will consume, or for a quantity you will consume. So it's 1% accuracy, so you can be sure if you have a MID certified product that the energy that is measuring is accurate at 1%. Also, you have international standards that you can use that are on the presentation. IEC 6253-21, IEC 61557-12. And here you have an accuracy. You have a class 1 that is that we recommend to be used because it's it's the equivalent of what is measured at the MID certification. It's also 1% accuracy, but if you are compliant with these standards, you can say that you have 1%. If you are MID certified, it's a certification from a notified body. It's more. You can be more confident on what is said. But in any case, the IEC standards, if someone is saying I'm class 1 according to IEC, it's okay. You can trust. So now that we say, okay, this is what I want to measure, how to select the right meter and for the right application. I have a meter. I want to measure in my application, in my installation, but what should I measure? Why should I measure? Why, etc. And for this, we can propose you to do a metering plan. It's a key stage in finding the right solution. If you do, the metering plan is okay. You need to analyze what is it's an operational and control tool for your building. You have to understand what is happening in your building, a new or an existing building. So it's based on measurement system that provide indicators, and it's to track your energy consumption of your building. So it's important to understand, okay, I need to know where, I will go to the next slide, it's more clear. I have to ask me some questions. Is the building consumption justified? I will explain. If I'm in an office building and I see during the day off that there is consumption. Okay, but why? Why do I consume in my building? Because it's a day off, and normally nobody is working and should not consume this day. And I see that yes, the lights are on, the HVAC is on this day, and so on and so on. But to see that, I have to measure and to see the detail of my consumption. So it's and where it is. So it's important to have a split in usage. Usage could be HVAC, but where? Locally, in some offices, the HVAC is continuing to refresh or to heat my offices without anybody inside, and it has no sense. During the night also, I have consumption. Why? And I see that the lights are still on in some offices because nobody switch off the lights. So really, I have to see where and when and which usage I have. So I really have to do this split and to see where are my main consumption and when it is and why isn't it off? Isn't it off? So it's really to see if my energy is used correctly and the potential gains I can make. And here I gave some examples, but you have many. Once you monitor, you can see many things. So it's important to do this metering plan before putting meters in your installation. And once you have this analyzed, you can say, okay, I want to go more in detail. I want to have a global view with a meter that gives me the global consumption, but then I want to know the consumption of lighting of these offices or this many offices or one office. and then I will be more precise. That means a meter, perhaps 40 amps for one departure dedicated to lighting for one office. It's possible. So define the meter is linked to which usage I want to monitor. Okay, so now I know that I have to monitor to see, but once I have all this data, what can I do? How can I see something? And for this, I need to monitor, to have something to see it. And here we are coming to communication, because to take the value on each meter and to exploit it, it's really not so easy to do, and not the easiest way to understand what happens. So let's go to the next topic. Also, which communication could be the right one in order to maximize the exploitation of this data. So what are the relevant communication standards for different applications? And here, Thomas, I think, yes, we can go to a questionnaire to you, to the attendees, please. Yeah, you can participate, and it will be a pleasure if you can participate in this webinar. In your opinion, what is the most suitable communication protocol for energy management? What is for you the better one that you use, that you think it could be used? And so please, can you answer this question? We will see after the results. And but click on the screen in order to give an answer. So we let a little bit time. Thomas, I don't know if what are the results for the moment. If you can see if it's interesting to get the result now, or if we have to wait a little bit. Can you please? We will have the result. Okay, good. 46% of participation. It's good. And the result is, can we have a result more detailed concerning the answers, Thomas? Perhaps I can, yes, sorry, I had to move. If we move a little bit, so, interesting. Modbus is in first line. You think 35% of you, so 1/3, is thinking Modbus is a more relevant protocol. Then we have roughly at the same level, 11% MBus and Kinix, which is not, I'm not astonished. And then 3% for other protocols. So it's good for me because it's the way of the presentation. I think these 3 protocols are really the main used. I see only 3% for other protocols. And I will explain also, and I agree with your votes, why which protocol can be used, because it's, and here with the vote we can see it's not only one protocol that is used. It's really depending on the application you will have. So the 3 protocols are important, and we'll see why. So first one, okay, without protocols you can also have remotely a report of your information. It's with pulse. You can have pulse outputs for each quantity of kilowatt hours or watt hours. You will send a pulse out. The advantage of the solution is it's really easy to install. It's only a cable, and you have pulse to monitor. But you can have only one data. It's one pulse information. For energy management, why not? Because as I said, it's only one value is important, is kilowatt hours. But you cannot manage the tariff and so on and so on. And on the other side, it's not a reliable solution, because if you lose one pulse, it's lost forever, and you can have not the right data at the other side and not the right index of consumption, because once it's lost, you will lose the quantity of energy that is not measured, and so it's not so reliable. It's easy, but not so reliable. So could be used for easy for small installation, but where you don't need to be too more precise on what you measure. Then we have MBUS. We saw that MBUS was also mentioned, 11%. MBUS is metering, means metering bus. A metering bus, so as it's called, is for metering, but globally for metering, it's metering of multi-energy. This protocol comes from more from water meters, gas meters, because it's a protocol that don't use to be powered on locally. So if you have gas or water with RF and so on, it's interesting not to have to be powered locally for safety reason, and not to bring power on and cable on the meters. For electrical meters, it's easier, of course. So it's mainly for application for multi-energy. This is important to know. It's a protocol that is it's mainly used for multi-energy. So it's you can wire it in parallel, in star type, in cluster. So it's for cabling, it's quite easy because you have many possibilities. Of course, the difference between this and the pulse is that you can have many information, much more information than only kilowatt hour. You can have the tariff per kilowatt per energy, and many other all the features that you can get from and all the data you can get from the meter. You can transmit, and in a quite high speed and quite high length, up to 1,000 meters offline. Okay, and you can have it wired Ethernet and also RF solution, radio solution. So interesting solution, mainly linked to multi-energy. Then we have Modbus. The first one in the vote we just get. So mainly application is for energy distribution boards, electrical distribution boards. It's the most used field bus used in distribution boards, and so it's when you have application for electricity in distribution boards. Clearly, it's a protocol that is used. Also, no problem concerning the reliability of the data, the speed. Only one disadvantage, I will say, is limited to if it's Modbus RTU, it's limited to 31 participants. So here you have a limit. So you have to multiply your concentrators to get the information. Okay, and you have to be really good in wiring. You cannot mix the cables. You have and it's only in daisy chain. So for the cabling, you have to be very precise. This is perhaps one of the disadvantages against MBUS, that is more flexible for the cabling. Okay. Then next one is KNX. I saw also 11% for KNX, and I think it's also for a different application. It has a sense for home and building automation. If you are in residential, in commercial, in small commercial, you have KNX for your home or building automation in order to control your blind shutters, your light, your heating. you want to do also energy management, and this we can understand. Energy monitoring and energy management. Just explain why it's important just before. And of course, it's interesting to put it in your global system. So Kinix supervision that you have. So it's interesting in this way to have meters that can monitor in Kinix. So and be linked in Kinix. So for this application, it's very interesting. Okay, now that we have, I think, a global picture concerning why I need to measure, what I need to measure, what is the application, and what is the communication, I suggest to see, okay, more precisely, more globally, perhaps, the application and the main benefits for this different kind of metering and communication. Yeah, I will split that in different market segments. First, on your left, you have commercial. We said it's interesting to have it in your main distribution board, distribution boards, sub-distribution boards, to see what happens. Linked to your metering plan, you want to see the detail of your consumption. So here, for your commercial application, it's part of your energy management solution. Because you have also power quality, don't forget it. So linked to the standards that I told you also, ISO 50001, IEC 60364, Dutch 8.1. It's interesting to monitor all this, and important, more than interesting. So for this, as I said, it's mainly Modbus and MBus that is used, mainly Modbus, because here we talk about main distribution board. And it's interesting to have the approval concerning accuracy, interesting for ISO 50001, because in ISO 50001, you have to be sure that what you measure is asked from the standards is the right value for 10 years. And with the MID certification, you can prove it, and this is interesting. So also MID is interesting for this application, this kind of application. In small commercial, two examples that you can have. You can have building automation with Kinix, what I said. I have, for my small commercial, could be a small shop, could be a dentist, could be a small commercial application. And I have home automation inside to control my light or my shutters and so on and so on. And I want to do a little bit, or perhaps not a little bit, but more energy monitoring. So for this, it's interesting to have Kinix, also meters, and also an application that we see more and more is multi-shops for multi-energy. I'm a big chain, or big or small, McDonald's, supermarket chain. I have many shops or restaurants around the country or worldwide. But I want to compare the energy consumption from one shop to the other, because I can learn from this. If one is consuming less than the other one, why, where, heating, HVAC, lighting, and so on and so on. I want to understand why it's better from one to the other, and what is the best practice in some of my shops. And here it's interesting, and it could be Modbus or MBus, in order to monitor and to see it globally, have a global view. And this is also a nice application. Collective buildings in some countries, it's interesting if you have many apartments that have the same energy supplier for electricity. You could have the same energy supplier. It happens in some countries. I don't know if it's okay, but it's very interesting then to do the cost split. You have this service to do for the different apartments to do the cost split, because of course if you have one supplier with 1 meter for all the building, then you have to do this this cost split and this billing per apartment. And for this, you need to have meters in each apartment. It's better if they communicate and that you can get all the data in order to do that. And of course, then it's good to have MID approval in order to do the bill. It's another application. And then we have an emergent topic that is a charging station for electrical vehicles, and also battery management, local batteries in residential or commercial. And I need to manage it to understand what is consuming for the battery management, and to save my to do my self-consumption of my energy, to store when, where, etc., etc. What is the need? What is the storage level? Sorry, and for this, I need to measure also. It's really booming for charging station. Also for charging station, if I have charging station in commercial, I want to do a bill for the one that is charging his car. I need to measure an accurate way. MID is the right thing, and I need to communicate also to get the information for doing in order to do the billing. I don't want to go to the charging station and to see what each time what the client is consuming. So I need communication, for example, Modbus, in order to get the information remotely. Okay, nice application. I don't say that we have all the application possible, but these are nice examples of where we have to measure. So now that we see that, what about Hager? On Hager side, we understood that it's important because of what I said, to have a relevant meter solution range. And for this, we acquired a company called Herholdt Controls, based in Italy, and it's 100% acquired by Hager in June 2017. Sorry. So it's a sub-metering specialist. Clearly, they are doing only that, only sub-meters. They do the design, the assembly, the test, and also MID certified, of course. And last year, the annual quantity were roughly 85,000 meters. Okay, and so thanks to this acquisition, we could launch a new meter range. As you can see, it's complete, easy understandable, with single meters on your left side and three-phase meters on the right side. Why it's important to have single meters? Because I said sometimes you want to see the details, and 40 amps is the right output in order to see the detail. And sometimes you need more. You have three-phase application, and you need to know that to use three-phase. So important in single phase, we have 40 amps, 80 amps, in order to answer the different needs, and a special one that is 3 times single phase, 80 amps. So you have a compact solution with 3 times single phase 80 amps. Compact and very interesting, because of course is doing 80 amps like the one you have just the line, the top line, and but only in four modules. So compact solution. And also it's interesting because when you have communication on it, which is recommended to have communication, Modbus or MBus, you have only one communication point. So one communication point for 3 single-phase application. So very interesting. So all these meters, single-phase or three-phase, can be Pulse, MBus, Modbus, or a special one. The last column is Modbus for Agardio application. And yeah, it's another topic. Our supervision solution, data logger and web server integrated, is called Agardio Manager. And for this, I said, Modbus, you have to be really good in your wiring of the communication. We have a plug-and-play solution with RG45. You can connect your meters in daisy chain easily. And this is very interesting. You can save time, and you are sure that what you connect is correctly connected. So all these meters are for production and consumption, export, import. All these meters have tariff inputs, so you can manage the tariffs. All these meters, or quite all the meters, are MID, except these 3 times 80 amps and the 40 amps basic one. And yeah, I talked about single phase, 3-phase. It's the same topic, I will say, concerning communication. Pulse, M-bus, Modbus, and Modbus RG45 connections for dedicated for Agardio Manager. And also we have a range that is easy understandable: 80 amps, 125 amps, and of course, for more than 125 amps, no direct measurement, but through external CTs, current transformers, because also we can propose a full current transformers range that is in our catalog. Also in split core for retrofit, split core that you can open. You can see it on the picture on the left at the bottom, and easy for retrofit. This is a brand new product that we launched this year. So also the CT output or input on the meters can be 1 amp or 2 or 5 amp. So you can manage it on the display. You can select 1 or 5 amp. Okay. So I don't want to go into detail here, but it's to explain how is the referencing of the product, and you can see EC is for the meter, or the letter after is Agardio, no communication, M-bus, Pulse, or Modbus. Then if it's single phase or 3-phase, and then the type, current range, and at the end, if it's direct connection, direct meters, or integrated, or via external current transformer for C. Okay. Also in communication, I forgot something. I talked about M-bus and Modbus that are integrated into the meter. We have also the possibility to add via add-on other communication possibilities. The one we launched this year, brand new, is the KNX add-on. So you can, via infrared communication that you have on the side of the product, you can see we have an infrared communication. You have only to put your module, your add-on module, on the side of the product and communicate automatically. And you can add other communication possibilities. Today we developed KNX. If tomorrow there are needs of other communication ways, we can adapt easily and put other communication. This is for the future, and it's future-proof, this solution, which is really interesting also. So KNX is also possible on the different products linked to this infrared communication ports. To sum up, because we are quite at the end of the presentation, and we will go to the question. We want to keep 15 minutes for the question. In summary, concerning the meters, Hager meters, linked to what I said, it's important to have a range that can answer all the applications that you need, linked to your metering plan. It's important to have accuracy. It's important to have reliable products. So we have easy, understandable meter range. I think it was clear. If you have questions, don't hesitate. Put it on the box, and we will answer the question. It's adapted to all applications, what I said, 40 amps, 80 amps, 125 amps direct, or via CT up to 6,000 amps, 1 or 5 amps CTs. It's interesting to have 1 amps if you have longer cabling to do, but mainly it's 5 amps that is used. Single phase and 3-phase. Okay. Various communication possibilities: bus, Modbus, RTU, M-bus, Kinix via add-on. Bidirectional for consumption and production. MID certified for the accuracy. Plug and play for Agardio solution, so easy to connect. And I didn't say it, but even up to 8 tariffs you can manage via Modbus communication. So depending on for M-bus, it's 4 tariffs that we manage on the communication. For Modbus 4, and in any case you have the tariff input into the meter that you can use for physical information concerning tariff, and you can use also an input on communication side, and as I said, it up to 8 with Modbus communication. And also adapted for retrofit, because thanks to our split core, new split core current transformers that we have. So with this, I think you are prepared to answer all your needs linked to your metering plan and what I said just before. So I'm now at the end of the presentation. I think we can switch to the questions. So, Thomas, you will help me, I think, to select questions that came during the presentation. Okay, can our energy manager store data? If can, how many data it can save up to? And okay. So concerning storage, no. What we store is the index of energy. So this is stored. It's linked to, of course, to certification. I said we need to ensure that if there is a power cut, we continue to have the right value and not to lose the value of energy. This is clear. For the rest of the data, as I said it, we have our Agardio solution, Agardio Manager solution. And then the data are stored at this level at the data logger. It's a data logger with a web server in order to use this value and what we stored, and in order to see curves and analyze and monitor and to exploit all this. Storage on the local way on the meter, all this data is less useful, because at the end you need, I think, a software in order to analyze all this. So what we store is the energy value in kilowatt hours in the different tariffs and so on and so on for different register, but we don't have the load curves that are stored locally. I think you have the answer. Can our energy meter set maximum demand? If yes, how to set the maximum demand so our electricity consumption not exceeds the maximum demand? Again, this is managed at it's as I said, it's energy management. So I explained it's to monitor energy and to see where you consume. What you are asking here is more power quality. So we have dedicated product for this. It's PMD, power measurement devices that have these functions and that can store also locally to answer the questions before. So we have solutions, but these are not meters. Meters are really based on energy management. But you can do it on another way, again, with our Agardio Manager solution. You can do these functionalities, but it's at another stage. I hope I answer your question. Michael, hello, Michael. Can you please provide some examples of use of 3 times 80 amps version? What is the application scope? Okay, very interesting. Application is easily, yeah. If you have to use more than one 80 amps single phase meter, and you have at least 3 in your installation. I said, depending on your metering plan, you could have interest to measure more than 3 times 80 amps in single phase for lighting, for I don't know, heating. For you have 3 times single phase 80 amps to measure in your installation. You have a compact solution if you have this 3 times 80 amps version. And on the other side, what is interesting, I told you, Modbus, for instance, Modbus RTU has a limit of 31 products that you can connect on the communication. So if you are limited, it's interesting because here you have the equivalent of 3 times single phase meter, 80 amps, and only 1 communication point. So that means you can multiply by 3 the metering points you can connect to your Modbus RTU. Very interesting. Easier to connect also because you have to connect only 1 time the communication on your product. So these are. I hope I gave you an answer, Michael, that convinced you. Does our energy meter be used together with auxiliary contact, such as buzzer alarm? Again, same answer than before. This is more than a meter. It's an auxiliary contact. It's more for power measurement devices. It's more linked to, it's less linked to energy management, but more to power quality. Then you have a threshold to give, and because if you want to put an alarm, you need to select a threshold. This we can do with power measurement devices, and we can do with Agardio Manager. So it's another level again. We can do, but not on the meter. The meter is really energy management. Next question, perhaps. What's the proposed function of resistor and alarms at energy meter terminal, and when to use a resistor? Very interesting. Thomas, I put some slides in addition if this question came, and perhaps if you can go to the, if it's possible to go to the, yeah, I will select. Here, and here I have the answer, I think. Just a minute. No, it's here. If you are in Modbus, for instance, you need a resistor at the end for the last meter or last device that you have on your bus. You need to put a resistor in order to close the communication cable, the two cables. And this is a resistor that you have to put at the end, only at the end, on both sides, at the end. On our product, what is interesting also, here we are going more in technical details, it's that you have integrated, the resistor is integrated into our 3-phase meters. So if you only connect with a connector between 1 and 3, you put this connection. You can see the resistor is integrated in the product, and you have nothing to do, not to put an additional resistor. It's automatic. You do have to do that on the last product that you have on your Modbus line, and you solve this issue. It's not an issue, but what you have to do to put the resistor at the end. The single phase meters don't have, because not enough place. We cannot put this resistor, and this resistor we have it also as an option, SMC 120 R that you can use, and you have to put the resistor for the last, if this meter is the last product in the Modbus line. And also what we have, if you are in RG45 with Agardio system, in order to do this, if for the last product for new line, we have also the solution with RG45 with a resistor integrated. Is what you can see here, and the reference for this product is HCG 467H. So again, I think we have here the solutions in order to answer the different needs. Okay. Next question, perhaps. Can you explain what the main purpose of MID certificate is? Oh, here I have a problem to understand the question. Can you explain what the main purpose? Thomas, can you help me? Do you understand what is the question here? Or I have problems to understand the question.
Stephane, can you hear me?
Yeah.
Yes, I suppose this is about some details about where the MID certification would be necessary.
So,
where,
okay.
when, case. That's what I mean.
Okay. Clearly, it's necessary in Europe. It's a European standard, a certification. So, in order to do billing in Europe, you cannot do billing if you don't have the MID certification. This is clear. It's measurement instruments. I can't remember. Okay, so it's a European. It's recognized in all European countries, but many times it's also used in outside Europe. Huh? And you have a notified body that certifies the product. So it's necessary if you want to do billing in Europe. So in your new countries, perhaps check if it's recognized or what is a local need. But at the end, it's in Europe. But you can say, okay, it's MID certified. It's recognized. And on the other side, what I said, it's when you want to certify your building ISO 50001, it's asked to be sure that during 10 years you are sure about the accuracy of your product. That is 1%. Huh? And with MID, if you have the MID certification, it's inside. It's certified, so you have nothing to do. So it's interesting. It's proof that your product is accurate and accurate for a certain time. And this is what MID can bring you as client on your installation. I think this is the answer. We are quite at the end of the presentation. Last question, perhaps. I imagine we are linked to the time. What is the main difference between tariff meter and sub-meter? The tariff meter is the one that is from your energy supplier. He wants to do billing for you with this tariff meter. So you can have a link to this tariff meter. He will give you, for instance, the tariff, in which tariff period you are, and it could be interesting in order to go to your sub-meters in order to have details. As I said, sub-meters are used in order to understand what is happening in your installation and link to your usage and and where you are using the energy. So it's more to go into the detail. It's yours. So it's more linked to this. Huh? I have connection problems. I'm sorry. I think we have to close here.
Can you hear me, Stephane? We have a last question. In case we have matters from different matters, could we communicate them via one protocol and one software? And is it easy to identify register address?
Yes, it's not a problem, because if you have, this is an advantage of the standards. If you have the standards, for instance, Modbus, of course, depending on the standard, you have a standard, but it could be different Modbus table that communicate. So the value could be at different place in your table, different address. But at the end, if your supervision can take can read different addresses for different type of product or different suppliers, of course you can use it. It's like KNX is an open standard. These are open standards, so normally no problem to read. Yeah, clearly no problem. It's okay. It's okay. Okay. Thank you. I think we will stop here, Thomas.
Yeah, there's just one last, very last question. I think it will be a quick answer, Stephane. Is it a good solution at a small company to install one submeter?
I really have connection problems.
Can you hear me? Okay, it seems you cannot hear me, Stephane. Then I would suggest we stop here for today. And Patrick, we will answer your question by email very shortly. So we will finish here. I would just like to thank you all for your participation to this webinar, and just to invite you to give us your feedback at the end of this session and help us to improve for the next webinars. We will have a break now. We will not have webinars for the month of August to give a summer break to our speakers and our attendees, but we will come back in September with more webinars to come. So follow us on LinkedIn, follow us from our website, and you will soon see our next schedule for the webinars in September, with many more interesting topics. And we will continue speaking about energy monitoring and energy management solutions for sure. So have a good day ahead, a good weekend, and a nice summertime for all of you. Thank you. Bye.